Okay. Well, it's 2:29, but I'm going to go ahead and begin. Welcome to my talk on the Test2 ecosystem. I'm Chad Granum, Exodus on CPAN. I want to start by thanking Grant Street Group, my employer. They sponsored my attendance at this event. We are hiring, so talk to me if you'd like a referral. So an ecosystem, complex network or interconnected system. In software development, they tend to sprout up organically. Vim, VI, Perl, a lot of different things in the computer world have ecosystems around them, but it's not unique to software development. For instance, drills. Very few people would buy a single-use drill. A good drill can accept a wide range of bits. It can do many jobs like creating holes, tightening screws, or driving screws and tightening nuts. It's a pretty well-established ecosystem. When you buy a set of drill bits, they will tend to work on most drills, and most drills will take most drill bits. The wide compatibility benefits everyone, the people who buy drills, the people who make drills, and the people who make drill bits. So a good quality drill is generally a valuable investment. Another example of an ecosystem is a tractor. Tractors are not usually single purpose. A lot of people think, oh, a tractor, it plows fields. But generally, tractors can take many attachments. They've got a PTO for power takeoff, 3-point hitch and hydraulic loaders, and you can make all kinds of attachments for the tractors. So plowing a field, mowing a lawn, digging post holes, leveling areas, clearing brush, moving pallets, the list goes on. And in general, it's possible for people to make universal attachments that will work on any brand of tractor. So a brief history of testing in Perl. First, TAP, the test anything protocol, was invented. Developers had to hand code statements like, OK, test passed, and they printed their own TAP output. Of course, this didn't last very long before people started writing routines like OK that you would find at the top of most of your test files. And they were usually the same, but sometimes people did them slightly differently. Eventually, some developers started building libraries out of these functions, such as Test.pl, which was included with Perl for a long time, and I believe might still be. But it was frustrating that a lot of these libraries didn't work together or might stomp on each other, especially if you were like counting the number of assertions you made. One library might keep a separate count from your library. Good things. So eventually, Michael Schwern released Test Builder, which was a compatible base for building tools. And the Test Builder ecosystem really took off with tools like Test More, Test Simple, Test Class, and a bunch of others. Later, Schwern and several others attempted to rebuild Test Builder to fix a bunch of issues and design flaws that they'd encountered once the tool took off. That project was eventually scrapped for many reasons. Then at one point, Schwern handed the test ecosystem off to me, and I got Test Builder and Test Simple. And initially, I wasn't going to make a lot of changes. I wasn't going to rock the boat. But then I got a request to change one simple thing. And I thought, oh, that's simple. Made the change. And if I'd released it, all of CPAN would have broken because it was the change of indentation of a comment. But people who were testing their test libraries were getting a big ASCII dump and then comparing it with regexes. And so changing the indentation of a comment meant for humans that shouldn't actually affect the TAP output would have broken half of CPAN. I decided that that was not a viable future. And eventually I came up with Test2 and was able to release that. And now Test Builder is actually just a compatibility layer on top of Test2. And it's been that way since May of 2016. So anytime you're using Test Builder these days, you are actually using Test2 as long as your Perl is fairly recent. Not even fairly recent, from 2016 or newer. Now, I don't want to minimize the efforts of everyone. This is a brief history. There's a lot of stuff that was omitted. So the Test Builder ecosystem was the first successful attempt at a base for writing testing tools. And the explosion was huge. There are so many test tools on CPAN that are based on Test Builder. But it did have some design flaws. You could not effectively implement die on fail or bail on fail, because if you fail as soon as the exception happens, you don't get the diagnostics of why the exception happened. And they were very disconnected in Test Builder. Validating testing tools, like I said, you're capturing the TAP output and comparing it to as strings. There were very few hooks available beyond basic text output. Subtests were possible and they were implemented, but anyone who looks at that original subtest implementation would run away screaming. So Test2, like Test Builder before it, is a tool platform. It is not just a set of things and that's it. It's something upon which you build more tools, like a drill or a tractor. So it's a useful platform, and when you use it, there's a lot of extensions, a lot of hooks that are there specifically so that you could add in new behavior as needed. Makes it very easy to write extensions. And if there's nothing compelling for you in Test2 out of the box, just look at the other things on CPAN and you might find something that makes it more compelling for you. So this slide is actually about 2 years old now. This is the brief list of Test2 tools that were available on CPAN 2 years ago. If I were to try and remake this slide today, you wouldn't be able to read it. But Test2 also supports everything that was written on Test Builder. There are about 4 exceptions to that, things on CPAN that didn't work with Test2 that no one cared about. So they might still be broken, I haven't checked. But it's basically, like I said, Test Builder is now compatibility layer in Test2. So over 7 years. You can mix and match tools from Test Builder and Test2. Loading Test Builder tools does slow things down marginally, but it'll still be faster than if you were using an old Test Builder before it was built on Test2. Just loading that compatibility layer can slow a few things down, but it's still really fast. A caveat to that. Test2 is much faster for long-running tests. Test Builder was slightly faster if you have a ton of test files that take less than a second each. But most people have much bigger test files. So this is a new development. As of Perl 5.40, which was just released in the last couple weeks, Test2 Suite is now part of core. So the initial set of tools that were built on Test2 are usable in core modules now. Also, Test2 Suite will soon no longer be its own distribution as it's going to be merged into the Test Simple distribution. So all the things that you see on the next few slides, well, not all, but most can be used in core modules. So got Test2 tools basic. This is just your basic tools. You've got OK, pass, fail, diag, note, and done testing. We've also got Test2 tools compare. This is the next evolution of isDeeply. For anyone who is familiar with isDeeply, in Test2, you just use is. Is does deep comparisons by default. And it provides a lot of extra things. For instance, you'll notice the T and the F there. We can just check that a value is true as opposed to checking what that value is on a deeper level. You can also check for false, does not exist, false or does not exist, or check that something does exist. There are a lot of things available for you when you're using these deep comparisons. You can craft some pretty creative ways of checking things. In fact, it's gotten to the point where I know several different people who have started using this for validating input on HTML forms and similar, or validating JSON trees. So it's a pretty rich set of tools that you can get from Test2 Tools Compare. Also, it gives you much better diagnostics, as you can see on this table here. It'll show you what path had a problem, what it got, what it was checking against, in some cases, what line number your check is defined on. And it even tells you what operator, which is useful, because if you're comparing the value 0 to the string 0.0, most people would expect them to be the same. But if you use string equality, it won't be. And you'll wonder why. This tells you what operator was used so you can fix your problem. Then there's the Test2 API. This is the heart of what makes Test2 special. First of all, you have the context object, which helps you track file and line number without needing to bump a level variable. It's your primary interface for writing new tools. And because you have to release it when you're done with it, you actually have a good hook point for things like die on fail and bail on fail, because you know that all of the diagnostics you intended to have printed are printed, so you can go ahead and bail out now. Let's see, it also provides intercept. Intercept allows you to capture any Test2 events that are fired within the block of the intercept, and then you can check them. You can check whether they pass or fail. You don't need to do any string comparisons. You don't need to rely on the text output of the test suite not changing. That there is a game changer. It is so much easier to test your testing tools when you can just intercept the actual events instead of parsing tap output. So Test2 IPC. This module, simply by loading it, makes it so that most of the cases where you're using threads or forking will just work without any extra effort on your part. There are only a couple of caveats. One is that if you start a subtest, fork in the subtest, and then have the parent process leave the subtest before the child does, that will cause an issue. But that's a pretty rare use case, and I have other tools available to help with those use cases. So then, case in point, Test2 tools async subtest. This is for if you're making asynchronous subtests. You can spawn off as many parallel subtests as you want with fork subtest or similar tools, and then just wait for them all to finish. And it'll take care of buffering them and outputting them and making sure that all the synchronization happens with little to no effort on your part. There are a couple downstream tools that use this, such as Test2 tools Spec and test class Moose, which, what's the name? Oddarch was consulting me a lot when he wrote test class Moose, and we were both working on similar libraries at the time. So that's why Test2 async subtest is really quite useful because it takes more than one use case into account. Speaking of Test2 tools Spec, this is very much like Ruby's RSpec for those of you who are familiar with it. You can create a block of tests. In this case, we're describing the foo block of tests. We're specifying something that should happen before all the tests are run, then something that should run once before each test set is run, then an after all and an after each. We're even creating a couple cases. That means all the tests will be rerun for each case. And then finally, we define our tests. And in this case, we're defining the test foo as isolation. That means it will automatically fork before running that test so that nothing it does can affect any other tests in this group. And we have test bar, which is just a simple block of tests. And then you can see all the output there on the right. I'm not going to go over all of it, but it shows you just how much is actually being done from such a little specification here. Test class Moose also uses async subtest under the hood, uses Test2 IPC. It's XUnit style testing. It's a modern replacement for test class, though it does have some limitations. It generally is run with prove running a script. So you'll generally have like a test.t test that then runs all your test class Moose tests. If you want to run just one test, you still have to go through that test.t. It's basically a second harness in between prove and test class Moose, which is something I really disapprove of, which is one of the reasons why I wrote a Test2 harness, which is on a later slide. So Test2 tools QuickDB is a tool I wrote that allows you to just quickly spin up an ephemeral database that will disappear as soon as your test is done. It can do Postgres, it can do MySQL, it can do MariaDB and Percona variants of MySQL, it can do SQLite. All you have to do is say, hey, give me a database of this type. It'll spin up your MySQLD or Postgres, give it just the very basic schema. You can load a schema file if you have one, and then you can connect to it, do whatever you want, and then it'll just go away when you're done, completely temporary. You don't need to have a system-wide or shared database server anywhere. It's just completely ephemeral, no passwords or usernames to worry about, and it's not going to be conflicting with anyone else on the system unless you use too many of them and you exceed your process count. Okay. Going back. I have a talk tomorrow, Chad's collection of topics, which does expand greatly on Test2 tools QuickDB. So if you're interested in that, come to that talk and talks much more about all the underlying how it works. Okay, Yath, Test2 harness, stands for yet another test harness. It's a modern alternative to prove. Its output is more human-friendly. It does still support tap, but in general, it's able to read the Test2 events directly, which means it's not lossy. Tap is a very lossy format, whereas the Test2 output is a JSON stream of events with a lot of details that tap would just omit. It supports a preload and fork model, which means you can load all the modules that your tests need and then fork off each test so that each test doesn't have to load it again and again. It's really handy. At GSG, for example, we were able to take a test suite that took 12 hours to run, and now we run it in 2 hours, partly because of preloading and partly because of beefier hardware. But without preloading, it would still take close to 12 hours. It's quite handy. There's hooks and plugins for additional behavior. So unlike prove, it's meant to be expanded upon. It's meant to have plugins and extensions. It can be taught how to run test class and test class moose tests without a .t file that sits between the harness and your tests. It's got full logging ability. You can tell it to output a log and then replay from the log. So let's say you have a test suite that takes an hour and you log it, and then you come back and you realize, oh, I forgot the -v, so I didn't see all that verbose output I wanted. You don't have to spend an hour running the test again. You can just replay the log. It'll take less than a minute to output all the verbose output that you didn't see before. There's also a web interface that allows you to look at all of the information that Yath captured. And I'll be talking about that on Thursday in my Yath talk. So hope to see you there. So some benchmarks. The current version of Yath that's on CPAN versus prove. So if you're just running prove on the Moose test suite with concurrency of 1, so no concurrency, takes 65 seconds on the computer I was using. If you then do a concurrency of 9, so 9 processes, takes 12 seconds. So Yath, when you're not using concurrency, can be a little bit slower. It took 76 seconds, so about 11 more seconds. With concurrency of 9, 14 seconds, so it's still slightly slower. But if you preload Moose and then run the test suite, 38 seconds. Preload it and then do concurrency of 9, 6 seconds. Just to give you an idea of the order of magnitude you can improve with preloading. Also, Yath has a much friendlier output. On the left, you can see the Yath output, and on the right, you see the typical prove output. Yath renders the subtests in a tree-like style. It colorizes things, so if there was a failure, it would be in red, and various other things come in different colors. Also, Yath is extendable in that you can create your own formatters. Currently, there's formatters for, let's see, there's XUnit output and there's another one I can't remember the name of, and I've got a few on there too. There's also the quiet but verbose renderer, which will only output if there's a failure, and it will then output the complete output of the test. So it's like you did a -v on any test that had an issue, but you don't see anything from the things that passed. Makes it much easier to grok the output. Yath is currently receiving an overhaul. The current version of Yath has a little bottleneck. While it can run many tests concurrently, it only has one process that processes all that output. So if you crank it up to, say, 90 concurrent processes, which I have done at a couple places now, the bottleneck becomes a thing that then reads it all in and audits it to make sure it passed. This overhaul changes the model so that each test that's run also has its own collector process that reads the output and its own auditor. So that greatly distributes the load and removes the bottleneck. It also fixes a scheduler issue that caused some IPC issues. All that's getting rewritten. Now, this slide is a year old. Last year, I said I expected it to come out within a couple months. That did not come true. However, after the last Perl Toolchain Summit, I've gotten very close, and this time I am actually hoping it will be out in the next couple months. If anyone wants to contribute to that, talk to me, and I can point you at the right branch and a list of to-dos. Hopefully, we'll be seeing Yath 2.0 soon. I will be demoing it to show you how complete it actually is in my talk on Thursday. So tools with rich ecosystems benefit everyone. In this case, we've seen what Test2 has done, but we need to be thinking in terms of ecosystems. When we write things and they start to show success, we need to start considering, okay, how might people use this? How might we make it extendable? Now, it's not necessarily something you want in version 0.0. First, make it work and then make it better. But once it starts to show that people might want to use it more, start thinking about how to make an ecosystem around it, how to allow other people to extend it. Also, please consider using Test2 for your future testing projects or even to update your existing projects. And if you come up with any great tools, please upload them for the rest of us to use. Thank you. Now, I will take any number of questions, and I can also show how Test2 is used if people want to see that kind of thing. I do not know how much time I have left. But quite a bit. Okay, so any questions first of all? If not, then I'll be switching to a different test2 talk I have ready. Yes. Mm. So Yath actually does support some of that. First of all, the new version of Yath, once it's released, will be able to read how many processes are on the system and automatically populate your concurrency if you want. Or you could write any number of plugins that are designed to divide things, like you said. Currently, there's the basic thing that takes the number of processes and splits up the jobs is itself what's called a resource. And you can write your own resource classes. I've written them for database allotment. But as for test specifically, Yath allows you to put comments at the top of the test that say harness dash and then something, something. And you can give it a concurrency level there. You can say, oh, this test, if assigned 4 processes, will use all 4 processes. Or this test needs 2 processes to run. You can also put things in such as, oh, this test conflicts with any other test using this keyword. So you can do harness conflicts Bob, and you can put that in 3 tests, and Yath will know not to run all 3 of those tests concurrently. It has a lot of capabilities for adjusting the concurrency and what will run when. And creating your own plugin to hook into these or to specify your own lists or check how many processes should be used. If that's all there, you can do that. And you can do that on the current version of Yath. You don't even need to wait for 2.0 on that one. Yes, and actually, we'll see some of this in my Yath talk on Thursday. We are getting a bit ahead of ourselves, but when you actually use Yath with a database, you can record that data long term as well. And whenever you start running the test suite, it can query the database and ask how long each test took last time, and it will optimally order those tests so that the longest ones will start first, so that you don't end up getting to the point where you only have one test and it turns out to be the longest one. You don't end up in that situation. And that's all built into Yath currently. Okay, I'm going to switch my slides over, assuming there's no more questions here. Let's see. Yep. There we go. So previously I've given talks on how to use Test2, and since I have a bit of extra time here, I'm going to go over some of the things here. I'm not going to do the basic tutorial because I think most people here can figure that out on their own. But going to talk about some of the expandability of Test2. So I'm going to skip over the basic tools, just these ones again. Got tools for testing classes so that you can test like, oh, is that okay, can okay, and unlike the ones from Test More, these are consistent with each other. The first is the class, second is the name of the class, make sure they're the same, or you can do an array ref with multiple classes to make sure it's all of them. And then finally a test name. With Test More, is it okay and can okay, did not have the same prototype and they did not take the same arguments in the same order, but most people assumed they did, and making the wrong assumption did not actually cause any failures. And so a lot of people have that wrong in code to date. If you switch from Test2 to, or from Test More to Test2, you would start to see those, or it should tell you what the problem is, yes. For the most part, there are a few differences between Test2 suites. So you would load the Test2 v0 class to replace Test More. There are a few differences, such as isDeeply no longer exists. Instead, you just use is. So it's not a one-for-one. Now, there are actually, let's see. So there is the Test2 bundle More, which I don't recommend people use unless you really need to move quickly. Basically, it is almost drop-in compatible with Test More. Use OK is gone, require OK is gone, to-do skip is gone. Like, just this list of things is gone. But otherwise, is exported as isDeeply. You have an is that works like the old is. So as long as you're not using any of these things or just quickly replace them, it's a drop-in replacement. But I don't recommend using it because the stuff that comes with Test2 v0 is just so compelling that the little bit of effort to update your test is worth it. You could. Okay, so anyway, so talking about bundles, Test2, you can use it through a few various bundles. Test2 v0 is currently the recommended bundle. If I ever have to make any backwards incompatible changes, I'll be releasing Test2 v1 and not actually changing v0. That way I don't break anything. And then people would just switch to using the new one on new tests. There's also a Test Simple wrapper for those of you who have Test Simple code lying around, but really at that point, just change, please. Okay, so back to the tools. That's some section now. So there's the defer tools, which actually, unfortunately, conflict with a new keyword that was recently introduced to Perl. So I might be changing this at some point. But it lets you defer testing for later. So this was useful to me when writing the tests for Test2 because I needed to make assertions that Test2 wasn't loaded yet. And so trying to test that Test2 wasn't loaded yet, chicken and the egg problem. So with the defer tools, you basically create a bunch of assertions where it captures those values. And then later, when you run do def, it does the actual assertions. That way you can run your tests before you have the test framework loaded and then actually execute them later. Not a lot of use cases for that one. I probably shouldn't have spent this much time on it. Encoding, you can set encoding. This is particularly useful for a harness to be able to read the encoding. Exception testing. Some of you have probably used test exception and know that there are so many caveats to that module and so many ways it can go wrong. Someone just uses carp always somewhere and suddenly all your tests break, that kind of thing. And it had to use some source filter, I think it was, to magically change something that's very finicky. So there were a few replacements for it that didn't have that problem, and Test2 has brought in the lessons learned and implemented similar tools to the ones that we now know are the right way to do it. So instead of just taking a block as the first argument, you say dies and a block. That encapsulates things better and you don't need to do any stack manipulation. Also of note, like is a deep comparison under Test2. So you can check deep data structures with like. So there's tools to test exports, tools to test references, a couple different subtest tools. There's the buffered subtest and unbuffered subtests, or streamed subtests, if you don't like the way it looks buffered. With buffered, you get this block around it. With unbuffered, you get the classic stuff that Test2 used to give you. Buffered is not really official to TAP, but neither is the unbuffered. The only reason subtests were ever like this is because no harness bothered to test subtests. So of note, unless you're using Yath, your subtests are completely ignored by the harness, and only the final OK saying whether or not it failed is looked at. Though Yath does actually parse subtests. It parsed both the buffered and unbuffered types. Tools to test warnings. Not going to go too deep into those. Comparisons. Now, I told you this was a rich ecosystem, and it has expanded greatly from what's listed here. So you get your is and your like, your isn't and your unlike, then you can do a match. So for example, match and mismatch is checking that that value does or does not match an regular expression. You can use that in is. That means you can use regular expressions with is, and you don't need to go to like to do that. Basically, you can think of like as a less strict version of is, where regular expressions are also automatically converted to regular expression checks. You can create custom validators. You can check hashes and arrays. You can do all kinds of things here. So, for instance, state, I mentioned you can check whether a value is true, false, that it's defined, does not exist, false and or does not exist. You can do directed checks here. In this case, like I said, match, mismatch. You can check that something is a specific number, at which point it knows to use mathematical operators instead of string operators. And you can also manually tell it string, which is almost pointless because it defaults to string if not told to use something else. You can check that something is an exact reference to something else, not just that it has the same deeply nested structure, but that it is an exact reference. You can create your custom validators like this, validator, and then it takes a code block. And then here's details of all the things that are available for you to look at in your check. You can check sets. You can say, is this in this set? Is this not in this set? Is this in this check set where it checks against a bunch of regular expressions? You have a question? No, okay. Array checks, you can specify, hey, this array should have these items. Oh, and by the way, item 3 is this, and end tells it strictly that the array should end here. Without that, you can also put etc for etc to say there might be other things in the array. We can ignore them. We don't care. Hash is very similar. You give it a field with keys and values, and then you can say either, hey, there might be other values and we don't care, or you can say, make sure there's no other values in this hash. And the difference between like and is what it assumes. Under like, it assumes there might be keys that you don't care about. And under is, it assumes there should not be more keys. You can do meta checks, like check that something is blessed, check that it's a certain type of ref, how big it is, things like that. And you can even do object checks where you call specific functions and make sure they give you the right result. Now, at that point, you're getting a little overkill, and you might think about dividing your test into more assertions as opposed to making a really deep compare structure. See, we've also got plugins for Test2, and you can write your own. They're really pretty simple to write. We've got bail on fail. First failure, it'll wait till the diagnostics are output and then bail out so that no more tests are run. We've got die on fail, which is the slightly less severe version of that. I'll tell you, when I'm debugging things, I'm using these plugins all the time. I generally don't leave them in after I'm done with the test, but when I'm trying to figure out why a specific test is failing, this tool is really useful. Exit summary, this one runs by default, and it just gives you a summary of what happened during the test. The srand plugin is loaded by default if you use v0, and what it'll do is it'll always call srand with the current date at the beginning of your test. That means on any given day, your random behavior will be consistent. So if it fails and you run it again, it will fail again. Whereas if you didn't do this, you might get a failure 1 in every 10 times you're running it. Also, it'll print that seed. So if you're going back and looking at historical results and go, oh, it failed on this day, but not these other days, it might be because of random behavior. And you can plug in the seed with this environment variable. It'll use that instead of the current date. And you can reproduce your failures that were due to random behavior. But that random behavior does change every day. So you're still getting the testing value from random data. UTF-8. Test2 has a UTF-8 plugin that really simplifies this for most people who can't be bothered to go out and look at the several different variants of UTF-8 modules, knowing which one affects your test, which one affects your output, which one affects how your file is parsed, because they're all different things. And in most cases, this plugin does the right thing. There might be a few exceptions, and I know someone in this room who disagrees with most of what it does, but you can always write your own version of the plugin. So there's also require extensions. These are things like, oh, this test should only be run during author testing. You could do your own legwork of creating a begin block that checks for the environment variable and calls skip all if it's not present, or you can just load this module. We've also got them for any environment variable you want to do. We've got things to say, hey, don't run this test unless this system can fork. Don't run this test unless this system has true fork, which is different. You can fork on Windows systems, but it's not true fork. It's actually threads under the hood. So you got fork and real fork. Skip the test if this module isn't installed. Skip the test unless a sufficient version of Perl is installed. Skip the test unless this Perl has thread support. Now, you can see from this example here, that this is not a trivial thing to implement yourself, including you've got a special case on 5.10 with GCC 4.8 that you'd have to account for. You got lots of things that are a royal pain to do yourself. There's a mocking library that comes as part of Test2, and it works by you create a control object. So you do Test2 mock new. You tell it what class to implement, what you're overriding, what you're adding. And then when that control object falls out of scope, all your mocking goes away. So you don't have to worry about unmocking later. You don't have to worry about contaminating other tests. You can also restore certain things or reset things at any given time. And you can collect metrics on what things you mocked were used. I don't know that I have examples of that here, but there are ways to collect metrics on what mocks were or were not used if you want to validate that a certain function was actually called. There's a bunch of tools that add sugar to defining those, like in this case, mock, package name, then your adds and your overrides, then later get rid of the mock. You can mock objects too. In this case, there isn't actually a class you define. It defines one on the fly for you. I find this tool extremely useful when I need to test an API that I don't really understand, and I just know that I need one function to return something and for it to just do nothing on any other call. This is your thing. It'll do nothing for most calls, but you can define a few calls where it does something. Really, really helpful if you're in a hurry, especially for debugging. I've talked about Spec and the bundles already. So context, like I said before, it's the heart and soul of Test2. One of the things I wanted to do away with was the test builder level variable. Who here has had to bump the Test2 or the test builder level variable? A couple of you. You know it's fraught with peril because all it takes is one extra stack frame being injected without your knowledge for everything to go bonkers. So what Test2 does instead is when you first start your test, you get a context object. And then that will get excuse me, the file and line number where the function was called and stash it aside so that you don't have to then ask what it was later because you already have it. And if you nest a tool, so let's say you're defining your own OK and you're calling OK under it, that nested call will just get the same object that its parent function got. So everything nested under the first tool will get the same context object that knows the correct file and line number. So you don't need to know how many stack frames are between the first and the last. And to help with discoverability, because I'm sure a lot of people didn't even know test builder level existed and were just putting up with the line number being wrong in their diagnostics. 1 minute left. Okay, good to know. I lost my train of thought. Wonderful. Oh yeah. Yes, it's so it's discoverable because the context object is also your primary interface for actually making assertions. You can't really write a test2 tool without knowing about context, so you never have the problem of not knowing how to get the right file and line number for your diagnostics. And when you're done with it, you do release, which creates that hook point for things like bail on fail, die on fail. And it also means every event that's produced under that context is tagged with the context that produced it. So you can always go back to your logs if you're looking at the test2 event logs and know which events were created by the same context, which is helpful to link your diagnostics to your assertions. Okay, now I've already done a Q&A, but I do have a few minutes left for Q&A if anyone has any more questions or wants me to dive deeper on anything here. Yes. So this documentation, it's on a GitHub IO page. I don't have the URL. Oh, here it is. Yeah, so hopefully that link is still good. It might not be. This is a very old set of slides. But grab me sometime in the hall and we can find the right URL. Okay, yeah, the GitHub IO URLs don't really show up on Google for some reason. But also there is the Test2 suite. Okay. Okay. So I will also say that I was given a grant a few years back to write Test2 manual, which is on CPAN, and it has a lot more than this. It's documented differently, but it has a lot more information. Any other questions? Special requests? Okay. Well, thank you for coming to my talk, and I'm very much on the hallway track, so feel free to grab me at any time. I love talking about this stuff.